Did you know that it's possible to land on Venus without a parachute or even a rocket engine? This extraordinary feat, discovered by Soviet scientists more than 50 years ago, was the result of decades of trial and error. What they learned about Venus not only revealed some of the most extreme conditions in our solar system, but also changed the course of space exploration. Join us as we delve into the fascinating story of the Soviet Venera missions, uncover the remarkable challenges they faced, and explore why we haven't returned to Venus since. Venus, known as Venera in Russian, represents more than just a planet in our solar system. It symbolizes a significant chapter in the annals of space exploration. The Venera program, running from 1961 to 1985, was a series of 16 missions designed to explore, discover, and map out our closest planetary neighbor. This ambitious project wasn't merely a scientific venture, but also a strategic move by the USSR to assert its dominance during the space race. During the early 1960s, Venus captivated scientists' imaginations far more than Mars did. Why was Venus such an intriguing target? Unlike Mars, which could be observed through powerful telescopes revealing a seemingly barren landscape, Venus was shrouded in thick, impenetrable clouds. This mysterious veil suggested that Venus might harbor a tropical environment, possibly teeming with life. The idea of a planet covered in dense rainforests, home to alien creatures, was a tantalizing notion for many scientists of that era. Carl Sagan, the renowned astronomer, popularized the theory that Venus's persistent cloud cover indicated a runaway greenhouse effect, resulting in extremely high surface temperatures. To validate these theories, direct exploration was essential. Thus, in the early 1960s, the Soviet Union embarked on a groundbreaking journey to Venus. In 1961, the Soviets launched their first probes, Venera 1 and Venera 2. This approach of launching missions in pairs was common during the early space exploration era due to the high likelihood of mission failure. The Venera probes were mounted on top of ballistic missiles, and the engineers hoped for the best. Unfortunately, both probes experienced system failures and failed to return any usable data. In 1962, NASA succeeded where the Soviets had faltered. The Mariner 2 probe, launched by the United States, flew within 35,000 kilometers of Venus and became the first spacecraft to perform close-up observations of another planet. During its 42-minute scan, Mariner 2 gathered crucial data about Venus's atmosphere and surface. It revealed surface temperatures reaching 237 degrees Celsius, 460 degrees Fahrenheit, and a dense cloud layer extending from 56 to 80 kilometers above the surface. This data supported Sagan's greenhouse effect theory and led NASA to shift its focus to the Moon and Mars, deeming Venus too hostile for further exploration in the near term. Despite this, the Soviets were not deterred. They remained committed to their Venus exploration mission, preparing a new wave of Venera probes. In 1966, the Soviets launched Venera 3 and Venera 4, both equipped with more robust designs. Venera 3 was the first spacecraft to impact another planet, crashing onto Venus's surface. Venera 4, however, achieved a significant milestone by successfully deploying a descent module that parachuted through the atmosphere and collected data before succumbing to the harsh conditions. The descent module of Venera 4 provided intriguing insights. At high altitudes, Venus's atmosphere was surprisingly similar to Earth's, with temperatures and pressures that were relatively comfortable. However, as the probe descended, the environment became increasingly hostile. The temperatures and pressures rose dramatically, ultimately crushing the spacecraft after 90 minutes of descent. This discovery suggested that descending into Venus was akin to diving deep into an ocean of thick, corrosive atmosphere. Undeterred by these setbacks, the Soviets continued their Venus missions with Venera 5 and Venera 6, launched in January 1969. Both probes experienced technical difficulties and could not withstand the extreme conditions. Yet, the Soviet commitment to exploring Venus remained unwavering. They refined their designs for the Venera 7 and Venera 8 missions. In 1970, Venera 7 achieved a significant breakthrough as the first spacecraft to successfully land on Venus, despite facing technical issues. It recorded surface temperatures of approximately 475 degrees Celsius, 887 degrees Fahrenheit, and atmospheric pressures 92 times greater than Earth's. This mission confirmed Venus's extreme environment, with temperatures high enough to melt lead and pressures comparable to being 1 kilometer underwater. In 1972, Venera 8 marked another significant milestone. It successfully landed on Venus with all systems functioning and operated for nearly an hour, providing more data about the harsh conditions on the planet. The Soviets' perseverance paid off with their subsequent missions, Venera 9 and Venera 10. In 1975, Venera 9 captured the first photograph of Venus's surface, revealing a desolate landscape of jagged rocks and sand-like material. Shortly afterward, Venera 10 provided images of smoother terrain, likely the result of ancient lava flows. The Venera 13 mission in 1982 was another remarkable achievement. It returned the first color photographs of Venus's surface, showcasing a flat, sandy landscape with a sense of depth as the probe landed near the edge of a cliff or hill. Venera 13 also carried a drill and surface sampler, analyzing the soil and finding it similar to volcanic ash found on Earth. One of the most intriguing aspects of Venera 13 was its inclusion of a microphone. This allowed scientists to capture the sounds of Venus, adding a haunting and alien dimension to our understanding of the planet. The microphone recorded wind noise and the sounds of the probe's operations, providing an eerie glimpse into Venus's environment. Venera 14, which followed shortly after, discovered another flat plain of smooth rocks, similar to the basaltic rocks found on Earth's ocean floor. This mission provided further evidence of the volcanic activity that has shaped Venus's surface. Despite these successes, the Venera program eventually came to an end. The challenges of operating in Venus's extreme environment, combined with the high costs associated with maintaining and launching such missions, led to the program's closure. The dissolution of the Soviet Union in the early 1990s marked a significant shift in priorities, and the technological advancements made during the Venera missions were not fully utilized in subsequent space exploration efforts. The end of the Venera program also highlighted a paradox. As our technology advanced, it became more fragile and less suited to withstand extreme conditions. The older Soviet technology, which was robust and capable of surviving Venus's harsh environment, was replaced by more modern but less durable designs. This shift in priorities and technology made it difficult to continue exploring Venus with the same level of commitment and resilience. The story of the Venera missions serves as a testament to the incredible ingenuity and perseverance of early space explorers. It underscores the importance of learning from past endeavors as we push the boundaries of space exploration. The achievements of the Venera program provided valuable insights into one of the most challenging and hostile environments in our solar system and set the stage for future exploration. As we look to the future, it's essential to remember the lessons learned from the Venera missions. The extreme conditions of Venus, with its scorching temperatures, crushing pressures, and corrosive atmosphere, remind us of the incredible challenges faced by those who ventured into the unknown. These missions also highlight the importance of resilience and innovation in the pursuit of scientific discovery. The exploration of Venus, with its extreme environment and unique characteristics, continues to inspire scientists and engineers today. The lessons learned from the Venera program have paved the way for future missions and advancements in space technology. As we continue to explore our solar system and beyond, the legacy of the Venera missions serves as a reminder of the incredible achievements of early space exploration and the ongoing quest to understand our cosmic neighborhood. Thank you for joining us on this fascinating journey through the history of Venus exploration. We hope you found this story as captivating as we do. Be sure to subscribe to our channel to stay updated on the latest discoveries and explorations in the cosmos. Don't forget to check out the video on your screen for more in-depth analysis and discussions about the wonders of the universe. The quest for understanding our cosmic origins and destiny is an ongoing adventure, and we're thrilled to have you along for every step of the way.